Hello, MTH287 class. This is section 2.5. As I promised you, got extra time for the test, so you get to spend some time with me outside of class. This is the differentiation of polynomials. You have learned how to find a derivative using the definition, which is actually the hard way of doing things. And a lot of times when you got functions and different types of functions, there are other techniques that you can find the derivative that's a little bit more easier to deal with. And polynomials is one of those. And on polynomials, there's a couple of rules. First one is called the constant rule, and it states that if you let f of x be a constant, now you got to remember what a constant is. If you graph a constant, it's a horizontal line. And so if it's a horizontal line, we know that if the slope will be 0. Remember I told you the relationship between the slope and the derivative is essentially the same? Well, if you have a function and it's equal to a constant, which is a horizontal line, the derivative is 0, as you might suspect. So that's the constant rule. And the identity rule is if you let f of x be equal to x. Now remember, f of x equals x is a diagonal line, and if you look at the equation itself, it is linear. And if you look at the omega x plus b, the slope is 1. So the identity rule is if you let f of x be equal to x, then the first derivative, i.e. the slope, is 1. So these two are kind of already known by you, but it's a couple of rules that's pretty important to use in polynomials in general. Now, this next one is the one that I promised you that it's going to be a little nicer. This is actually called the power rule. And it's the derivative of x to a function f of x equals x to the n. And if n's an integer, you got, actually it's true for any other besides integers as well, but we're going to start with the integers. Then the first derivative is equals to n times x to the n minus 1. So what that basically means is you multiply the n, which we'll call a multiplier, times the number in the front. So n times 1 is n, and then you bring down the exponent by 1. So just a quick example, what I mean by that is if you have f of x equals x to the third, and if you recall in class, when I was finding the derivative of x to the third, I had to use that x plus h cubed, and then I had to multiply that thing out, and I never did it really in class. I never showed you how I did it. I made a big long expansion like x cubed plus 3x squared h plus 3xh squared. Remember that? So that was what we did in class. Okay. Well, the derivative of that, without all that work I did in class, is simply the first derivative is simply take the 3 and multiply by 1 is 3x, and then bring your exponent down by 1. And remember, when I was doing this in class, I told you guys there's going to be a way that you don't have to take 5 or 10 minutes to find the derivative. You can do it in 3 seconds. This is it. So the function x cubed, the derivative of that is 3x squared. So, and if you have a string of those, so if you have like f of x equals x to the third minus 2x squared plus 4x minus 5, then the first derivative can be found very, very easily. Whereas this would cause you a lot of grief if you're using the definition of a derivative. So you remember 3x, that'd be 3x squared, and then you take the 2 on this one and multiply by the negative 2, and that's a negative 4. And then you bring the exponent down by 1, so make the 2 now a 1. And then this exponent is 1, so 1 times 4 is 4. And then to be x to 0. Now, hopefully you guys remember what x to the 0 is. So it's 1. And it's going to be 1 times 4, which is 4. And negative 5, if I take the derivative of negative 5, remember negative 5 is a constant. So the derivative of negative 5 is gone. It's 0, technically. So technically there's this plus 0 out here because the derivative of a constant is 0. Of course, we never deal with that, so we just erase that. So the first derivative is 3x squared minus 4x plus 4 in this situation. Now, if I was doing this by the definition of a derivative or the four-step process, then it would take me quite a few minutes to do that. And a lot of people at this point will sit there and start throwing things at me because they think, why didn't you just tell us this in the first place? They don't all work this way. Polynomials is one of those special functions that actually is easier to find the derivative of. They're not all that simple. And polynomials is one of those that are come out really super nice. And but when we take the derivative of sine and cosine and tangent, which we eventually will do that, they're not as easy to do the derivative like these are. So this is one of our really nice functions. And so, fortunately, when we're learning derivatives, one of the first ones that we use is the polynomials, using the definition. And so that's why people make that connection. Well, why didn't you tell us this in the first place? Well, it's because it's one that we need you to practice on finding the derivative by the definition. So when we get to the other ones, that this little technique doesn't work. You have a way to do it by the definition. So anyway, but in order to use this power rule, now this is something you kind of can tune out if you want. This is actually going to have two parts to it. I'm going to do a few examples in the next little piece, so I'm going to take this out here. And if you don't want to learn this, this is actually for the students who are going to continue in math. So if you don't want to see this part, it's not really important as far as knowing how to do the problems. So the second part I'm going to on this little video that I'm going to do is going to be basically examples, and that's when you want to pay attention to. So you might want to tune out here if you don't want to see this, but again, it's for those students who are going to be moving on. And but anyway, so this is the x to the n, and find the derivative by the definition. Well, it becomes this. So now what we're going to do is we're just going to be using this rule, power rule, but it would be nice to know, why does the power rule work? And the reason it works, it's because of the definition of the derivative. So if you have f of x equals x to the n power, well, the first derivative by the definition, as you've seen this one quite a few times, okay, it's f of x plus h minus f of x all over h. So remember that h is the gap between the x coordinates, and what we want that gap to do is go to 0. And so the 2 points that are secants become a tangent. That's just a reminder of that. So we got limit as h approaches 0 of f of x plus h minus f of x over h. So we're going to plug this x plus h back into the power function. So it becomes limit as h approaches 0 of x plus h to the n minus x to the n all over h. Okay? So this is f of x plus h, this is f of x, this is h, and of course this is the minus. Now at this point, we can't really simplify this out very easily. Okay? This actually requires the binomial theorem. And this is usually taught in college algebra up until recently. We've kind of taken it out of the course, unfortunately. So, but it used to be actually taught in college algebra. So if you've taken college algebra within the last, I'd say 10 years, then you may not have ever seen the binomial theorem unless you saw it in high school. So I keep referring to, you got this in college algebra. Well, this is one of those things that you didn't catch it in college algebra. So, so it's the limit as h approaches 0. Now, x plus h to the nth power is actually by the binomial theorem. And I'm going to write these out. And it's not going to make much sense, but this is what it is. It's n0. That's what that basically means, is a combination. You have n and you choose no other items. And it's x to the n. It's the first x to the nth power. Then what you do is you increment the combinations, n taken to the 1, but you decrease this exponent by 1, makes that n minus 1, and then the h appears. The next term is n choose 2 at a time. And again, guys, this is just x plus h to the n. I haven't dealt with this yet. I haven't dealt with the h on the bottom yet. All this mess here that I'm spreading out is the individual terms of x plus h to the n. Now remember, when I had x plus h cubed, I had 4 terms. And the first 4 terms, the first one was x to the third, the next one was 3x squared h, and that 3, that was found by this combination right here. And then the next one was 3xh squared, which was the third term, which was found by this next term I'm about ready to write down. So these are the individual terms in general form. So this is n choose 2, x to the n minus 2, h squared. And you keep going until you get to the very last term. And the very last term is n choose n of h to the n, which is this h to the nth power. Like I said, you're like, boy, I wish I would have been one of those students who tuned out. Well, you're with me now. You got to stick with me to the end. So this is the x plus h to the n. So if you spread all these terms out, there would be n plus 1 items. So if this thing was to the 5th power, if this thing was to the 5th power, there would be 6 terms listed across here. And you're like, well, I don't know what these are. It doesn't matter, not at this point. Okay, again, it's the binomial theorem. If you want to know what the binomial theorem is, you got to look that up. So, but anyway, this is x plus h to the n, and then minus x to the n. That x to the n, oh yeah, it's this one right here, minus x to the n. And this is all over h. Okay? So these terms right here is what this x plus h to the n was if you were to expand it out. But here's the good thing about this. This term right here is 1. If you have n items and you don't choose any of them, there's only one way of doing that. So this x to the n right here is only 1 times x to the n, which cancels with this x to the n down here. Now, if you recall, what I told you guys now, what would happen is everything would cancel out except for anything that has an h in it. And I've got that down here too, because look, this one's got an h, this one's got an h, they all have h's left because this x to the n that didn't have an h canceled out. So that one's gone. So that is equals to the limit as h approaches 0 of n choose 1 x to the n minus 1 times h plus n choose 2 x to the n minus 2 h squared plus dot 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 out to n choose n of h to the n all over h. So this first term gone, this last term is gone. No more h's on those. But everything else, on every term that I have listed here, even including all this ellipses, every term in between has an h in it. So what did I say? When there's an h on the top of everything and there's 1 h on the bottom, you cancel them out. Here's the cool thing. So this is equals to the limit as h goes to 0. Factor the h out at the top. Then you have n choose 1. Again, it doesn't matter what that is right now. X to the n minus 1 plus n choose 2 x to the n minus 2 h to the first, because you took one of the h's out, plus dot 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 plus n choose n times h to the n minus 1. You're like, why now it's n minus 1? Because I took one of the h's out. So everything here in these brackets have one less h in them. But that's okay. Because now what I'm going to do is I'm going to cancel these out. Now if you look at this term and all the terms in between has an h in it. And remember when we were talking about the definition of a derivative, you continue this until you cancel the h's out, and now you can plug h0 in for the h. But here's the cool thing. If you plug 0 in for the h, this goes away because of the h to the first. Because 0 times anything, whatever that is still 0. And all the terms in between will be 0 because they all have an h in them too, including the last one. So from here to here goes away because of the limit. What's left is this baby right here. The question is, what is that? So this is n choose 1 times x to the n minus 1. Now, here's where I got to convince you of something. What is n choose 1? N choose 1 is if you have, let's say you have 7 items, and you got to walk through the door with 7 items, but you're only going to carry 1 item at a time. How many different ways can you bring in 1 item? Well, you can bring the first item in. That's one way. You can bring the second item in, or you can bring the third, fourth, fifth, sixth, seventh. So there's 7 different ways to bring 1 item in. You can't bring 2 in. You can only bring 1 in. So if you're bringing in 7 items, there's 7 ways. So 7 choose 1 would be 7. If this was 16 choose 1, it would be 16. Okay? So this one right here, it's going to be n choose 1. Well, what's that? That's n. So this is going to be n times x to the n minus 1, which is what I was saying. This is what 261 students would do. And they would actually have to show this on an exam probably. So that's why that class is more theoretical, not our class. We get to play with the fun stuff, but we don't have to prove much fun stuff. So, which makes this class a little nicer. So, well, depends on your perspective, I guess. But anyway, this is the power rule. And it's pretty cool because it makes finding derivatives on polynomials a lot nicer than going through the whole routine. So, but anyway, now this is going to be the end of the first part, and I'm going to go to the second part. And what I'm going to do is I'm just going to work a few of the examples, and that's going to be a very short video. So, because they go rather quick now, because before they took a while because we had to use the definition. These we're going to be using the fast way to do it. Okay, so hang on and click on the next link. Thanks.